Welcome back. Today's lesson is 10.5, deciding where to start dividing. As always, pause the video, grab a marker board or marker, and then come on back once you've gotten your materials. Our ICANN for today is I can use the standard algorithm to divide a 3-digit number by a 1-digit number and properly decide where to start dividing. You have learned to divide 3-digit numbers, and today you will be learning what to do when there are not enough hundreds to divide. So in our first problem, Roberto is using craft sticks to make picture frames. He has 125 craft sticks, and he uses 6 sticks for each frame. How many frames can he make? So in our givens, I know I have 125, and I'm going to divide that into 6 frames, 6 sticks per frame. So I could 1, 2, 3, 4, 5, 6. And then that will tell me how many frames I can make. So my equation will be 152 divided by 6. Now, something that I always like to do when I first start with division is I like to put my multiples along the side so I can reference them. So 6, 12, 18, 24, 30, 36, 42, 48, 54, and I stop at the times 9. All right, so when I first start dividing, I always start dividing in the place with the greatest value. And here, the place with the greatest value is the hundreds place. So when I set this up, I know that I'm going to have 1, 2, 3, 4, 5, 6 groups that I'm dividing this into. And I have 100, 10, 20, 30, 40, 50, 2. Now, if I have 100, am I able to put 100 into 6 groups? Well, no, I'm not, because I only have 1, and I can't put 1 each in these 6 groups. So what I need to do is I need to exchange this out for 10 tens. So I'm going to take this and exchange it for 10 tens. So here I go. There's 3, 4, 5, 6, 7, 8, 9, 10. So what I'm actually showing here now is I have 15 tens. So I'm not going into 100, I'm going into 15 tens, because 100 is the same thing as 15 tens. So if I were to take these 15 tens and I would divide them out, I'm going to do that now. I'm going to start giving 1 each until I can't give any more. I'm going to go do that now. So as you see, as I divided those out, what happened was each group got 2. And I'm going to record this up here in the tens place. Each group got 2, which means I used 2, 4, 6, 8, 10, 12 of them. So I can subtract away 12 tens, which left me with 1, 2, 3. So 15 minus 12 equals 3 tens. And then I'm going to bring down that 2, and I have 3 tens and 2 ones left. Well, I can't easily split up these 3 tens, so I need to actually trade these 3 tens out for 30 ones. So I'm going to do that now. I'm going to trade out for 30 ones. All right, so as you see, I traded those 3 tens out for 30 ones, plus the 2 that were already there. And now what I have to do is I have to just start putting those 30 ones into these 6 groups. Those 32 ones, into these 6 groups. But if I look at that, I know that I can only evenly do it to 30, which is 1, 2, 3, 4, 5 times. So if I were to go here, only 30 of them would go in there. So I'm going to go do that now. So as you can see on my board, what I've done is I started just splitting those up, and I used 30 of those ones, and it left me with 2. And how many times did I go in there? Each group got 5. So So I'm going to record up here. Each group got 5. And I know that 6 times 5 equals that 30. And then I had a remainder down here. That remainder is 2. All right, let's try another problem like this. All right, in this problem, Madison is making iguana keychains and she's using pom-poms. So she has 145 pink pom-poms. And I want to know if there are enough pink pom-poms to make 36 keychains. So how many pink pom-poms does Madison have? Well, we know that Madison has 145 pink pom-poms. And how many does she need for each? If we look at this, it says there's 4 pink pom-poms for each keychain. So I'm going to just break this up to 1, 2, 3, 4 for each keychain. And then that will figure out how many she can make. So to solve this equation, what we're going to do is we're going to take 145 and we're going to divide that by 4. And I'm going to draw a picture of this one for us. So I have 145. And I know that I need to put these into 1, 2, 3, 4 groups. And I like to put my multiples along the side to reference. So I'm going to do 4, 8, 12, 16, 20, 24, 28, 32, 36. So I have to decide. In this, I like to start subtracting in the place with the greatest value. So start dividing here, the hundreds place. Well, I have 100. Can I put 100 into 4 groups? Well, no, I can't because there are not enough hundreds to put into each group. So then I have to start dividing the tens place. So I would actually be trading out that 100 for 10 tens. So we're trading out this 100 for 10 tens. We no longer will have this. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we're doing actually 14 tens. We're looking at the one that's closest to 14. Can't be over 14 because I actually only have 14. So 12, 16 would be too many. So I could use 12 of them. So we go 1, 2, 3, 4. We go 5, 6, 7, 8, 9, 10, 11, 12. So if we look at this, I couldn't go another 10 because I only have 2 left. So what happened here is I know that each group got 3 tens, and I know that 4 times 3 is 12, so I subtract away 12, leaving me with 2 tens. Well, 2 tens is the same thing as 25 ones. If I were to put 25 ones into 4 groups equally, I have to think of the one that's closest to 25 without going over, which would be 24. Okay, so I could put 24 over here, so I could trade these out real quick for 21s. So now my picture is showing 25 ones. And what I would do is I would start putting all of these in. I know I have to use 24 of them. So I would go and I'd use 24. So I could use these 4. 1, 2, 3, 4. Then I would go and use 4 more. So I'm going to cross out these 4. 1, 2, 3, 4. I could use these 4. 1, 2, 3, 4. I could use these 4. 1, 2, 3, 4. I could use these 4. 1, 2, 3, 4. I could use these 4. 1, 2, 3, 4. 1, 2, 3, 4. And you notice I have 1 left, so I can't do it again. So that I did use 24 of them, because that's 6, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I used 24 of them. And that was 4 times 6. 1, 2, 3, 4, 5, 6. And that left me with 1 left over. 5 minus 4 is 1. So 36 with a remainder of 1. So she did have enough to make 36 keychains. She had 1 pom-pom left over. 1 pom-pom left over. So we're going to try this problem. 455 divided by 7. So I'm going to write out my multiples of 7. 7, 14, 21, 28, 35, 42, 49, 56, 60, 3. All right, so what we're going to do now is we have to decide where to start dividing. So I always like to check the place with largest value first, which is here is my hundreds place. So if I have 4 hundreds, can I put them into 7 groups? So let's think of my groups down here. I have 1, 2, 3, 4, 5, 6, 7. I always think that in my head. If I have 4 hundreds, could I put 4 hundreds in those 7s? No, I can't. So then I think if I have 45 tens. 45 tens, well, yeah, I could put 45 tens into 7 groups. Which one is closest to 45 without going over? Well, that's 42. How many times is that? 1, 2, 3, 4, 5, 6 times. So we're going to put the 6 right here above the 5, and we're going to subtract away those 42 tens, and that leaves me with 3 tens. We have to bring down those 5 ones, and now we had 3 tens and 5 ones, or as I like to call that, 35 ones. Now, could we put 35 ones into those 7 groups? We sure could. And look, we could actually put it in an exact amount. If we go 1, 2, 3, 4, 5 times, we could put them in 5 times. Put that 5 above the ones place, and we know that 7 times 5 is 35, and we would use all of those ones and leave us with 0 ones left. We don't have any remainders, so we wouldn't put an R up here, R0. We just have 65 as our quotient. Let's give another one a try. Let's try one last problem. Let's try 342 divided by 6. So let's put our multiples of 6 here. 6, 12, 18, 24, 30, 36, 42, 48, 54, and that's times 9. So I always like to think of how many groups I have. 1, 2, 3, 4, 5, 6. And if I had 300s, could I evenly put them into 6 groups? No, I can't. So now I'm thinking of 34 tens. Well, I could put 34 tens in these 6 groups, but I have to come to closest to 34 without going over, which is 30. So I'm going to subtract away 30, which would give me 1, 2, 3, 4, 5 times. So I'm going to put 5 times above there, which leaves me with 4 tens, and bring down that 2, which is 4 tens and 2 ones, which is the same thing as 42 ones. Well, if I look at this list over here, right away, I see that 42 is on my list. It would go exactly 7 times. 1, 2, 3, 4, 5, 6, 7. Because 6 times 7 is 42. I would use all 42 ones. So 6 times 7 is 42. So 342 divided by 6 equals 57. All right, so today what we did is we used the standard algorithm to divide a 3-digit number by a 1-digit number and properly decided where to begin to dividing. So go visit your Google Classroom and check out what your teacher needs you to do today. All right, see you next time.